So our next speaker is Mehl by the Free Software Foundation in Europe, and he will talk about how openness contributes to security.
Yeah, thank you for the invitation. Hello everyone here in this room and also on the stream. Today, as the stage manager said, this is about, I would say, a contradiction on the first side. So we have two aspects here. We have IT security and free software. IT security, or security at all, that's something I connect with, I don't know, James Bond. Secrets, secret agents and agencies, and in general, things that are hidden that are not to be shared with someone. And on the other side, there's free software. Free software is about sharing, about community, about openness and transparency. So how does that fit together? And this shall be the topic of the next 45 minutes. And I hope I will be able to explain to you why the openness of free software can benefit IT security, which is more about secrets. Who am I? I'm Mehl, working for the Free Software Foundation Europe. And so that you know a little bit about my background, shortly about the FSFE, we are a charity that empowers users to control technology. And I say this because I find this control technology quite important, especially if you look at IT security. Because, do you know that? It's an ex-KCD comic. I love it so much. I look at it quite often to remind me of how important control of technology is. Because this is how most people would imagine the nuclear chain of command in the USA. So there's the democratically, ideally elected president, and he has the power to fire a nuclear weapon or do something else, and with a press on the red button, he can toggle this chain of command down the pipes and, well, execute an action. And that's great. I mean, this is democratically elected, the president. He can do what he's supposed to do. But if we take technology into consideration here, it looks like this. There has to be an engineer or engineers who installed this red button, who programmed it, who said, well, if I press here, what happens to them? It's not the president who said that, and it's not the president who installed that, it's an engineer, it's technology in the end. So who controls this technology? Who has elected the engineer to do this job? No one. And this is why control over technology is so important. And all of this fits together into IT security because, of course, you want to have this red button be secure. And how we do that is quite simple, with free software. Free software gives any user 4 essential freedoms, a total of 4 freedoms. And these are, first freedom, the freedom to use the software for any purpose. So if you have a free software, you can use it for any purpose, for your own individual use, in your university or school, or also as a business. You can found a business, you run the software there, and make big money with it. There's no limitation for that. Second freedom is to study the software. So you or anyone else, your friends or someone you contracted, can have a look at the software, at how the software works by looking at the software source code. And basically have a look in the machine room of the software, see what it does with the data, does it send it somewhere else, is there a bug, is there a security flaw, something like that. You have the freedom to do that, and there's no restriction. The third freedom is to share the software for any purpose with anyone. So as soon as you have the software, a free software, you can give it to your friend, to your family, to another business. There's no limitation in copying a free software. And the last freedom is to improve the software. So you can modify it. Since you can look at the code, since you can use it for any purpose, you can also modify it. You can add a function, you can delete it again. You can do it for the better or the worse. Doesn't matter. You have the freedom to modify this. And only if a software gives you these 4 freedoms, you can call it free software. If only one freedom is missing or more, then it's proprietary or non-free software. And these freedoms, just as a reminder, come to you with a license. So you get a legal document where it explains to you what you're allowed to do with the software and under which conditions. And so that you're not being confused, free software is also often called open source, but it's basically the same thing. It's these 4 essential freedoms. And these 4 essential freedoms can make software more secure. We come to that later. So now to the actual topic. You didn't come here to only hear about free software, but let's speak about something that's really high in the media, high in the press: cybersecurity. Right? So I don't know what's the situation here in Switzerland, but in Germany, I think there has almost not been a week since 10 years where not a cyber agency, cybersecurity defense agency, administration, whatever, got founded, and where a politician, decision maker, whoever said something about cybersecurity, how important it is, and I don't know. Like with every Trojan attack, with every hospital that has to be shut down because of that, there's new agencies, new experts coming up in the field. But I would dare to say that only 20% of the people who actually speak about cybersecurity know what it actually is. And let's hope we can fix that. I'm not a born security expert either, but I think I got it somehow. And this man showed me or explained to me how, or gave me the starting point to understand it. Hands up, who knows who that is in this room? No one. Sorry, people on the stream, I cannot see you. So this is Bruce Schneier. Bruce Schneier is an IT security expert, cryptographer, wrote a lot of good books, and one of his first book, I think, was Secret and Lies. And already in 2000, he wrote the following sentences. Like, the book is big, 500 pages or so, but this sentence hit me and really made me understand, like, from the beginning what security is. Security is not a product, it itself is a process. And that sounds like a really simple sentence, but in it there's a lot of like explosion power, because that's what so many people get wrong. They treat security, or especially IT security, as a product. So they say, well, now this hospital got shut down, so we invest, I don't know, 1 million euros, dollars, whatever, and then it's secure. Or we hire this firm to fix it for us. Or we buy this product, this antivirus product or this firewall, and then it's done. No, security is not a product. It is a constant process. And therefore, there cannot be one single solution to increase or improve IT security in general, because it's a complete process from the beginning to the end, and in the future and back to the past. So everything. And to give you an impression of how this could look like and how these parts are intertwined with each other, I prepared this slide. It shows a few steps of these processes, from the obvious to the not so obvious. So if I go on the street here in Zurich and ask a few people what IT security is and what's important, then I bet 90% would drop at least one of these terms. Of course, it's code flaws. So you're a programmer, or you have a company with programmers in it, and they make mistakes. They're humans. So they write something, they didn't know or didn't look close enough, and now there's a security bug. This happens, right? Then there's encryption. Especially since the whole Snowden affair, we know how important encryption is, so that no state actor, no criminal can ideally read our sensible data, our sensible information. And there are countless of algorithms how to encrypt data. So how to get a sensible private information into something that cannot easily be decrypted without a password or so. So that's important, but since there are so many different algorithms and since technology evolves, some encryption mechanisms get obsolete or cracked, or there's a backdoor. So if you already do encryption, then you should also take care of a proper encryption. That's important as well. Then, of course, fixing bugs. So a programmer make a mistake, or the encryption is bad, you have to fix it. That sounds simple, but it's actually really like, who does the fixing? You, someone else, a company? So this is important as well. But as I said, this is obvious. One step further. Oh, dependencies. Modern software engineering does not really, or in only minimum number of cases, is self-contained. So you do not write anymore a program and it's out there and standing for its own and running on its own. No, there's a dependency, an operating system, a web server, a database, something like that. You do not usually write that on your own. And this is great because you do not have to reinvent the wheel, but you can use dependencies. But who does check the security of an operating system or of a database or web server? That becomes tricky. Are you then, do you have to take care of security fixes in those products as well? Probably not, but someone has to. Then there's a human factor. Imagine you're a CTO in a company and you made sure that your programmers are trained to have perfect IT security, like to write their programs flawlessly, you have the best encryption experts on board. And then there's someone in support who just leaks your customer data because they thought, because they got scammed, social engineered. So, the best IT security, like in written code, is not worth anything if the humans behind it do not understand IT security. So this is important as well. Or we have customization. You're in the company and you have a product, it's great, and now a big client comes and says, it's great, but we have to please add this tiny function to it, or remove it, or modify it. And you say, sure, for you I do this. But the problem is now you have two software products. And then another client comes and another, and you have a wide range of different software products which are identical in the largest scale, but what about these tiny functions or things that you changed? Are these security related or can they be exploited? So you have to maintain them. And now, next step. Oh my gosh. Now it becomes complicated. Business strategy. I know a major router supplier or manufacturer. Hello. And we've noticed, this has been 1 or 2 years ago, we've noticed that this manufacturer in his products, like in this modems and routers, they supported a protocol to access shared data on the network. So basically you were able to put your hard disk on the router and you were able to access it. But this over a protocol that has been obsolete and deprecated since years because there have been so many security issues with it. And one of the FSFE asked them, why do you do that? You should have the security experts to tell you this protocol, don't use it anymore. And said, we have one client or a few clients that are relying on this protocol. They would otherwise go to another vendor who still supports it. So this is a business strategy decision. And to be honest, I can understand it. I mean, if we just get rid of everything that might be insecure, the IT security experts and the programmers would not get paid anymore. Because, you need to take care of your clients and you have to match these expectations. So in the end, it's again, you cannot do it 100% right. You have to take also other factors into consideration. Or we have support cycles. You have a product and now you work on it on newer versions, no matter whether it's free software or proprietary. And for how long do you support the old software versions? 1 year, 2 years, 3 years? If you buy a mobile phone today with an Android, you can bet that after 2 to 3 years, you won't get any security updates anymore. We can now argue about why this is good or bad, but in fact, it's a decision by the company, and you should take care of that, whether you use a product or whether you ship a product, no matter which type. How long do you want to support it with software fixes? Because that's then your responsibility. And really complicated is liability. So now, all this chain, there's some mistake there. Someone did a mistake. Who's liable for that? You as a company, are you liable if one of your support people leaked sensible customer data? Yes, probably. Okay. But what about if a dependency broke? That's not your fault, that's not your code, but you shipped it. So are you liable? What about customization? Is now the client liable because he demanded it or something else? Or if the encryption mechanism was somehow insecure and you were not able to fix it in the same time? So this is really complicated, and this is just an example. These are just 9 points out of how complicated this IT security process is and how intertwined with each other, with other factors. So let's take this into consideration when we speak about IT security. Now I'm working for the Free Software Foundation Europe, and my job is, of course, to always think from the free software perspective. So I started thinking about, well, how can free software be a solution here or do something for the better? Does it work like on this picture? Like we take one free software license, a GPL license, an MIT, Apache, something like that, and we combine it with an existing solution, like we make a proprietary product, now free software. Does that solve all IT security issues? Yeah, probably not. So that doesn't work. But there are different or various security benefits that we see how free software can improve or can add to that. So first of all, there's transparency. You know, free software is transparent. We had this with the 4 freedoms already. The good thing is now you can have independent security audits. So someone you know, a friend, yourself, a company you hired, no matter how, can check the software. Or some stranger on the internet can check it, can see whether there's some bug inside of there, can fix it. And this increases trust, which is also important, especially if we speak about public infrastructure and public code. So this is already great. Like, you do not have to rely on the goodwill or good words by a software company, but you can actually have a look into it. Then there's prestige. That may sound a little bit awkward, but let me explain. Usually in non-COVID time, I go to a lot of conferences and we have booths there. And then often software developers come to the booth and say, well, free software is great, what you're doing is great. And, oh, thank you, yeah. Yeah, I do software development myself. Yeah, but not free software. Why? Yeah, well, you know, there's this stuff in my code and these ancient bugs and yeah, perhaps also some security fixes. I just don't want to say, like, to release that because otherwise it would be embarrassing for me. I say, wait, stop here. You ship functionally disabled software or software where you know that the code is not really good to people, strangers on the internet, and you don't inform them basically about why this is bad or that your code is bad. So what I'm saying with that is, if someone is forced or really willing to open up their code as free software and releasing the code to the public, then they take a closer look, especially for a company who has a face to lose. They do this usually. So this a little bit outside pressure of releasing code can be a big benefit. Then we have synergy effects. We especially see this in shared projects. So speaking about public administrations. So there are a few software projects, free software projects, that are shared by multiple public administrations, public bodies, also universities. And the cool thing is they create a community around the product. Like this can be participation software or platforms and so on. And this is really great because usually in the proprietary world you have one entity that takes care, in this case, about IT security. But the point of view is of course quite fixed. They see it through their own classes, through their own eyes. If you build up a community with different expertise, different interests, then you can also increase security because, well, you look at it from another angle and you have people who actually care for the product, for the software, who are not just consuming it. And last but not least, but perhaps most importantly, free software gives you independence. Again, proprietary software has one entity that ships the software. And if something is going wrong with security-wise, you have to rely on this single entity, and you cannot do anything about it. There's a recent example, a few months ago, there's a Citrix, or was Citrix. Citrix is some kind of a terminal server software. So this is especially used in larger institutions like universities and hospitals. So basically that there's one central server or multiple, and people can just connect to it and run their terminal client, whatever. It doesn't really matter. So it's really used in a lot of institutions and big ones. And there has been a security issue, or meanwhile multiple ones, and a really big one. And so there were universities, hospitals, public administrations, and many more, and companies, of course, who couldn't do a thing to fix this. Like they could perhaps tinker around a little bit and follow some advices on the internet, but in fact they had to wait for the single manufacturer to solve the issue. And it took really, really long. Also for all the security issues that are now popping up in the same software or software suite. The good thing about free software is that you can improve the code yourself. So perhaps not yourself, because you may not be a software programmer, but someone on the internet, on a mailing list, a friend, a company that you hire can fix the bug for you. And if these things come up more often, like if you're really not satisfied with a software product or an entity that ships a software, even free software, then in the worst case, you can also fork the project. So basically copy the code and start it with your own community or on your own. So in the end, this is also a pressure for the entities distributing the software, but it also gives you confidence and independence that you can take over control over your technology. So these are a few security benefits that we see here. And this leads me to the conclusion, and a few other things, that free software is a necessary but not sufficient component of IT security. What do I mean with that? So free software is not a sufficient component. So imagine you have a free software and you do everything right. You build up a community, you open up the code. It's all great. You react to issue requests and bug reports by people, and you have a really lively community around it and a great free software. But that does not make your software automatically secure. You still have the human factor, you still have your own decisions when it comes to security, and everyone knows there's no 100% IT security. But free software is necessary on the way towards the 99% IT security, because it has these many security benefits that proprietary software does not have. Proprietary software has no synergy effects. It has no transparency, no accountability. So these are factors that you have to take, like you have to take what you can get in order to make a software secure, also from a bigger perspective. But of course, where there's light, there's also shadow. There are a few challenges, and I don't want to hide them away, especially when we speak about free software. Now, what about responsibilities? Now we have this shared project between public administrations, and that's great. Who takes care of that, of the security in this case? Is it City Barcelona or City Madrid or City Zurich? Is it the university? Is it the community? Do we just put our responsibility away? So someone has to take care of security and has to keep this in mind, ideally multiple entities. And that's important, and this often gets lost. We have dependencies. Now, we already had this. Dependencies, especially in free software, are great. I mean, to be honest, most software that you would write from a beginner or advanced perspective, if you ship this as a whole, probably only 10% of the code would be yours. The rest is by someone else, like all the infrastructure, the operating system underneath, the web server, the database, the framework around it, or other dependencies that you pull in. You do not have to reinvent the wheel. You can stand on the shoulders of giants. And this is great about free software. But how many of these dependencies can you handle? Also, not you as an individual, but also a company or public administration, a state that develops free software. So there's no ideal answer. It depends on your budget, on your will, on your project. But you have to keep this in mind. So this is a huge advantage of free software, but it's also a challenge. Then we have these threats, I would call them. There's this hypothetical argument that if you open up yourself too much, then you're attackable. So in a free software community, everything is quite transparent. Like there's a bug report, and this is out in the open, and everyone can see it. And it's potentially a security issue. So this is, of course, a risk that there's information out there, the code is out there, it's quite open, and everyone can see what's going on inside, and potentially also the issues. But is that really a problem? I would say, or we can argue about that there are a few cases like, I don't know, military. Probably the US do not want to open up their software, how they raffinate nuclear material for their atomic bombs. Okay, let's take that. But to be honest, how many instances, how large is the percentage of projects, software projects, that are this dangerous to open up, where you do not want to give too much information out there? So I would say in the most cases, the advantages of free software, of openness, outweigh the disadvantages. And then there's resources. That's really important. That's a critical issue, I would see, especially in free software. There is, or there was, the case of Heartbleed. Perhaps you know it. Heartbleed was the name for a security vulnerability of OpenSSL. OpenSSL is mainly used for encryption, and also especially in web servers. Like you used OpenSSL in some way if you communicate to Facebook, log into your email account, do whatever. Like this is encrypted traffic and encrypted data. And this is important. But what was quite unknown before this incident is that this very important foundation of secure internet was maintained by one single person. And this person got not even really paid for the job. So we have giants like every major of the big 5 IT companies, probably every other company, us individuals, public administrations were using this and not giving a single cent back to the original author. And yeah, there was a security incident and the person said, well, so I can try to fix it, but hey, it's a one-man show, let's be honest. And this is critical, this is really bad, that's a bad situation. And to be honest, a few things changed since then, a few organizations and initiatives popped up, but I still find this critically underrated, this risk of missing resources, especially in the free software world. That we see so many reusers and users of free software, but especially large entities do not really give back. And this is something that we have to fix. And now we come to the common counter-arguments, like I already went into this right of negative line. And people sometimes ask me why I put up this slide, because I would undermine my own position, but I would say no. If you, after this talk, perhaps hopefully speak with someone else about it, your family, a friend, a colleague, and speak about, yeah, free software is great for IT security, I bet that quite a few of them will bring up at least one of these arguments. So there's criticality. This is especially true when we lobby for free software in political processes. So we speak with decision makers and tell them, well, put up a free software policy. Like if you fund software as a state, as a government, make it as free software. And then they come up with clauses like, okay, free software is great. We make everything free software that has been financed by the state, but only for non-critical projects. I would say, well, really? The opposite is true. The opposite would be right. Or not the opposite, but like opening up everything would be right. Especially for critical projects, you want them to be transparent, you want them to be free software. Given public infrastructure, you want to have this as free software because every one of us wants to have a look into it. We have to trust in it. And therefore, for critical projects, you want to take in all security benefits that you can take. Then there's security by obscurity, a common phrase. Nobody will explain it to you by that, but again, if you speak to people and tell them about, opening up software, they say, well, no. Again, I do not want to open up. That's a security risk for me. Everyone would see what's going on inside of there. And the thing is that free software, the transparency actually allows you to fix these issues and to spot these issues. Because what we see in proprietary software is that there are still security issues. Attackers, criminals, security experts can still find out security flaws with proprietary software like Windows and everything else that you know. There are constantly security problems there, and the code is kept secret. They don't know the code, but they can still find it out. So better than investing into keeping this code secret is to go open and to take in the community to help them or together fix security issues. Then there's often the counter-argument of unprofessionalism. When you speak about free software, then there comes the point where they say, well, no, free software is nothing for professional, like for commercials and for companies. This is a thing for hobbyists, like people working in their cellar at their mom's house and working on free software. And again, quite the opposite is true. Before that, like in earlier editions of my slide, I wrote in their company names, but I just now write variable company. Because you can take any major company that you know, and I bet they will use free software. And most of them have founded their whole business model, meanwhile, on free software. So free software has, in this regard, won already. It's in some areas, server market, virtualization, cloud, free software is everywhere. Free software is the driving force. So let's get rid of this unprofessionalism. Free software is there, and now we can make use of it. And then there's sometimes the argument of when I speak to company owners, I say, well, I cannot make money with free software. And I would say, yes, in some regard. You cannot just sell licenses. That's not a business model that works with free software. But you can sell support, customization, and so on. Implementation. So I accept that there are a few business models, and we can speak about the details later or after the talk. There are some business models that do not work with free software, I admit it, but I would bet that the majority does. And this should not be an argument against opening up your code and using these benefits. So to summarize all of that, I gave a lot of information. What are our demands? What is the gist of it? I think it's important to have free software for critical infrastructure. What is critical infrastructure? These are public transportation, traffic, energy sector, things like mobile networks. Like we all use it. We use it to chat with each other and to make phone calls. Emergency services use it. So this is critical infrastructure. Hospitals, how to file your taxes digitally. And it's important that we, especially as citizens, can trust this infrastructure and can make use of it, that it's transparent. So there, free software is really, really important. We want this to open up. Because otherwise, our mobile networks are mainly operated by, depending on the country, by 3 or 4 companies. And I would say this is not really good. Or operating systems, oftentimes still a monopoly. And the thing is that also the state, we should not underrate this, the state invests a lot of money into software themselves. They write a lot of software. And for this, the next point is important. Public money, public code. So if the state, governments, with tax money, invest in software, write software, it has to be public code, so free software in the end. Especially for critical infrastructure. Like we've seen that's now with these anti-corona or corona tracing apps. I don't know what's the situation here in Switzerland. But there finally some state actors understood that we need free software for that. Because people have to trust in the software. They do not want to know what's going on inside. Perhaps they cannot find it out themselves, but they can ask friends and can read in the media. So this whole principle of public money, public code is crucial for IT security, but in general for digital sovereignty. So this is like the keyword that you hear in Brussels and other capitals so often, in so many debates, digital sovereignty. unfortunately, still not many people do understand what's behind of that. That we have to be able to control the technology. We as individuals, but also we as a city, a state, a country, or even more, Europe. We must be able to control our technology. And this is important. And last but not least, we demand more sense of responsibility by everyone, like by you as an individual, but also especially by companies and states. They use a lot of free software already, and the use and reuse of free software will increase. And especially for those who invest already a lot of money and have a big budget, it's important that they also invest in the future of this software that they reuse. So they reuse existing free software components, that's great, but they also have to give back. They have to understand what they're using and who's maintaining that, and to have an interest in keeping this software up and running and secure. And this would already improve a lot of things that or issues and challenges that we see in the free software world. If major reusers would feel responsible for the software that they use and reuse. So, this is already the end of my talk regarding sustainability. Thanks to all the supporters of the FSFE that support our work. You can also become part of it. And now I hope we have some time for questions and answers. Thank you.
So, thank you, Max.
Oh.
Okay, if you have a question, please raise your hand.
Do you use non-free software? And yes, and if yes, where? Yeah.
I personally, not on my business stuff, I would say, like the FSFE stuff. I have a phone where there's really only free software on it, at least what I can control. If we now take a look in the firmware of this phone, then you would also find proprietary stuff, that's for sure, and that's a bad situation. But privately, yes, I have to, unfortunately. And I have to, like, I'm not forced by it by law, but by friends, basically. So I have to use some apps, for instance, that are non-free software, unfortunately. But I'm pressing hard on improving that. But speaking about I'm forced by law, in Germany, if you want to file your taxes, you can do this by paper. But this is not really convenient for individuals. If you want to do it digitally, then you have to use non-free software for this. And this is something where this public money, public code would come into play, that no one should be forced to use non-free software. So yes, I have to use non-free software for some things, but I try to avoid proprietary software wherever possible. And I would say, like, how was it? A few weeks ago, my mom bought a new laptop. It was Windows 10 on it. I wasn't really able to use it anymore. I didn't really understand the concept. So I can proudly say that I'm in the free software world since quite some time already.
Thank you for your talk. You mentioned the challenges about free software. You had the slide with the 4 points, and I was wondering if you want companies to use free software. They're very keen on maintenance and guarantees that in a certain amount of time, like in the few next years, there's like at least one person that they can contact to fix bugs. How would you, I don't think you mentioned that. What's the solution there when it's when the software is actually free, like with the guarantees, and because you have to sell it somehow to the companies and give them some security for the future?
That's an interesting point. So it really depends on the type of free software, I would say. I mean, there's free software that is only maintained by one single person. It's out there, and everyone is free to reuse it. So there, of course, you cannot force the original author, be it one human show or like a small community, to keep track of the maintenance of the project. There is no, in the licenses, there's no guarantee that this will be maintained forever. There are a few issues with that already, where maintainers drop out and seek other people for help, and sometimes these are abusive people who use their newly gained power basically for bad things. These things happen. But what companies, if they really care about this, and they want to use free software, then I would appeal to the sense of responsibility. There speaks nothing against asking the maintainer, hey, do you want to become a freelancer for us and maintain this project for 2 more years or for 1 year after another, and perhaps also include a few improvements in there? So this is what I would call a sense of responsibility. And you can also think about free software companies. So companies that really ship free software professionally and also make money out of that. Not by selling it directly. You could do that. Like I forgot to say that free software doesn't have to be gratis. So without a fee, you can also have a fee, but that's a business model that is not often used. But you can like ship your product and make money with support contracts, basically. So I can become a customer of Red Hat, for instance. And I have a certain degree of confidence that this will be maintained. But on the other hand, I can ask back, where do you as an individual have the guarantee that the software that you bought, the proprietary software, will be maintained forever? The company can be bankrupt. They can just give a damn about it and just say, well, we have one person, let's take an intern, he will take care of the security, you know? Like there is no guarantee. You can make contracts, and you can contract also free software developers or free software company. And depending, like you should check then the dependencies that you have. Like you can look down the road and can become complicated to do that. Can look down the whole supply chain basically and see, well, this is a weak spot. There's a software that hasn't seen a security update in 3 years. That's bad. So either we get rid of this dependency, or we hire someone or invest some of our own energy into fixing this. This is a lot of freedom that free software offers you. You wouldn't have this with proprietary software. But it's also responsibility and a challenge. So yes, I hope this answered your questions. Thanks.
Perfect. Thank you for the insights. I appreciate the overview in that sense. I have one question relating to a component you mentioned in the word free, right? I mean, there's nothing that's really free in essence, because even people who do produce software for free, at some point you need to get something back on that level. So to your point, I think it's great to have free software. I think everybody uses some form of free software in some project. But you also mentioned, hey, you know, there's certain things that maybe are not ideal for free software. So probably the nuclear proliferation protocol is one of those things. But there's probably some others as well. How do you think people are set to deal with this idea of doing non-altruistic work? So you mentioned like Red Hat's a great example. I think they did a great job with Linux. But how do you see like a model that works to maintain things where it's not just based on the intrinsic motivation of somebody who develops this, but like really a business model behind it? Because I think that's one of the main things that's holding people back from producing free software. Like, is there anything that you guys are doing to push this forward? Are there any best practices?
To understand you correctly, you're asking whether we have a program or whether there is a program that a software developer can make a free software and make a living out of that, basically, or?
Yeah, okay. Or what do you recommend for people to do? Or how do you transition from a business model that is based on proprietary software today?
Oh, these are two questions then.
Yeah.
Then now you're asking from the company perspective, right?
Yeah.
Okay, so it depends. So if you're a software producing company, I think the first step would be to, like, other way around. If you want to go free software, then I think you can, if you really want to. It depends really to have a balance of these advantages and disadvantages that you may have moving to free software. Like you ship proprietary software and now you want to do free software instead. So depending on the business model that you already have, this might be complicated or not complicated. There are software companies that for them, it would not be a problem to ship this as free software because their main target is already companies who may not have the budget to install, support, update the software themselves. So what these companies are already paying, or these customers are already paying, is basically support. So you can open up the code and you could do the same business model per se. You could also even sell it. Like you can sell free software. with the risk that someone else then takes it and makes a fork out of it, or I don't know, gives it to a friend or to a befriended company. That may be true, but the support stays with you. So you build up like an ecosystem of services around it, customization and so on. There are companies or business models where I would say this is not possible with free software. It would be, for instance, in algorithms. So I know a company that invented an algorithm for car sharing, I think, like for ideal use of car sharing. And this is like they solved an issue with an algorithm, with a code that no one else seemed to have solved before. And opening this up would, of course, like make it really easy for the competitors. And I would say, well, you cannot open it up. But what you can do is open up the libraries that you use for it. Like you also have dependencies. You have to write libraries yourself. And it may make sense to share this as free software, to build a community around it. Even the biggest proprietary software companies, Microsoft, Facebook, Google, they do a lot of free software already, and they base their business models upon free software. I do not want to say that Google, Facebook, Microsoft are great, like from the privacy perspective and user rights, not so good. But they work with free software, and they transitioned their business models to free software, and that does work indeed. And yeah. So I don't know whether this answered your questions. It's a really complex issue. Yeah.
Okay, if there are no more questions, then let's thank the speaker again.
Thank you.